Good morning, boys and girls. Today we will begin with the next process of gametogenesis, that is oogenesis. In the last class we have talked about spermatogenesis. Now today we will learn about oogenesis. Okay, the second process of gametogenesis. Now what is oogenesis? Oogenesis is the process of formation of haploid female gamete. Alright? So oogenesis is the process of formation of haploid female gamete, that is ovum. Right? So during oogenesis, there will be formation of haploid female gamete, that is ovum, from the ovaries. Here, and it begins from the time of embryonic development. Right? So it begins from the time of embryonic development. That means when the female fetus starts developing, or the female embryo starts developing, from that time the process of oogenesis begins. Now there is a difference between spermatogenesis and oogenesis. Spermatogenesis begins when the male attains puberty, but oogenesis begins from the time of embryonic development. Clear? Okay, now next one. Now, listen very carefully, right? Now, during the embryonic development of the female fetus, or let's say during the first gestation period, alright? During the first gestation period, or during the first embryonic development period, during the first period, there will be around 16,000 of primary follicles. Alright, because last time we learned about the transport section of mammalian ovary, where we are learned about that in the medulla part we will see the follicles at different stages of development. And what are those follicles? They were primary follicle, secondary follicle, tertiary follicle, and the mature Graafian follicle. So during the embryonic development, alright, we will see the developing stage of follicle, that is primary follicle. It will keep on developing. By which process? By mitosis, cell division process. Because during mitosis, the number of cells keeps on increasing. Alright, there will be an increase in the number of follicle cells by the process of mitosis, cell division. And let's say during the second gestation period, second month of gestation period or second gestation period, the number of primary follicles it will usually increase, let's say up to around 6 lakhs. Alright, the number of primary follicles increases to around 6 lakhs during the second gestation period. Around 5th gestation period, or during the 5th embryonic development of the female fetus, the number of follicles keeps on increasing by the help of mitosis, cell division, and it will reach around 1 million to, let's say around 1 million to 2 millions, or more than that even. You can say around 5 lakh or 5 millions to 7 million. Let's say it is around 5 millions to 7 millions. And what happens that after that, the number of primary follicles keeps on shrinking. Alright, the particular term that we use is called atresia. The primary follicle starts shrinking. So as a result, at the time of birth, there will be around 2 millions of atresia, where they will go shrinkage. As a result, the number of primary follicles at the time of birth will be around 2 millions. Now, most important thing, after the birth of the female, alright, not a single oogonia or the primary follicles will be added or will be formed. For example, let us say that at the time of birth, okay, let's say, at the time of birth, let's assume that if the number of primary follicles was 100 in number, alright, let's say, at the time of birth, if the number of primary follicles was 100 in number, then after birth, there will even not a single follicle will be added. That means after the birth of the female child, this particular number of follicles will not be increased because the follicular formations will not be there after the birth of the female child. Whatever may be the number of follicles before the birth, it will be there. And from this number of follicles, there will be the formation of ovum. So not a single follicles will be added after the birth of the female child. So this is the difference between the oogenesis and the spermatogenesis, because spermatogenesis begins at puberty and after that it keeps on going continuously. But in case of female, the oogenesis begins from the time of embryonic development, from the time of the development of female fetus. Clear? And after the birth, not a single follicle will be added in case of female fetus or in the female ovary. Clear? Now next thing, what are the different process or the steps of oogenesis? Like in case of spermatogenesis, there were 3 major phases: multiplication phase, growth phase, and the maturation phase. Similarly in oogenesis, alright, similarly in oogenesis, which begins from the time of embryonic development or the development of female fetus, we will find three important phases or stages. So what are the 3 phases of oogenesis? The 3 important phases of oogenesis are: number 1, we call it multiplication phase. Number 2, growth phase. And number 3, we call it maturation phase. Okay, so there are 3 phases of oogenesis. First one is multiplication phase, where the number of follicles has to increase in number. And over here, the type of cell division that occurs is mitosis cell division or mitotic cell division. In the growth phase, the follicle has to increase in size. Alright? And in the maturation phase, there must be formation of ovum. Clear? So this particular phase we will discuss one by one. So, like in case of the testes, we have got the cells of the germinal epithelial, which has got germ cells and the Sertoli cells. Similarly, in the ovary, because ovulation or release of ovum occurs in ovaries. Okay, so similarly in ovary, we will find the cells of germinal epithelium. Okay, so we will find the cells of germinal epithelium or the germ cells. So what happens is that a single primary follicle or the germ cells, clear, it will undergo rapid mitosis cell division. What type of cell division? Mitosis cell division. Now mitosis cell division means equational cell division, where the number of cells keeps on increasing with the constant number of chromosomes. That means the number of chromosomes in the parental cell and the daughter cell remains the same. So look over here. So the germ cells of the primary follicle cells keeps on increasing in number. Alright, it keeps on increasing in number by the help of mitosis cell division. So from a single parallel cell, it will divide into two daughter cells. Again, this will keep on dividing to produce a large number of daughter cells with the constant number of chromosomes. So these particular parental cells or the primary follicle will be diploid to end with the complete set of chromosomes, and the respective daughter cells which are produced from this parental cell will be also diploid. So it will be 2n. Why? Because it has undergone mitosis cell division, or we will also call it equational division. So this particular phase, we will call it multiplication phase. We will call it what? We will call it multiplication phase, and this particular daughter cells will be termed as oogonia. O-O-G-O-N-I-A. Oogonia. Yeah. Now, if we try to one, now this particular oogonia will undergo, or will enlarge in size. It will enlarge in size. Now it will be known as primary oocyte. Here, so this particular oogonia now will enlarge in size, and now we will know as primary oocyte. So now this particular phase, now we can call it as growth phase of oogenesis, where the oogonia will simply enlarge in size. Now how does it enlarge? By absorbing the nourishment or the nutrients. And from where does it get the nutrients? Mainly from the cytoplasmic part. And if you remember, we have learned about the XAVIER'S follicle, we have learned about causative follicle, where we will find the fluid-filled cavity called antrum. Alright, A-N-T-R-U-M. We will find the fluid-filled cavity, which is known as antrum. Here, now this antrum contains a liquid called liquid follicule. Now that liquid follicule or the fluid present in the antrum will also provide the nourishment to the developing oocyte or developing ovum. So as a result, this oogonia will simply enlarge in size and now will be known as primary oocytes. Now listen very carefully, alright? Now once it will form the primary oocyte, now this primary oocyte has to undergo meiosis cell division. And we have got two phases of meiosis, meiosis 1 and meiosis 2. Clear? But at the time of puberty, carefully, at the time of puberty or after attaining puberty, only these primary oocytes will complete the first meiotic division or meiosis 1. Only after attaining puberty. Before that, these primary oocytes will never ever complete the first meiotic division. So where it will be arrested? So the primary oocytes, alright, its division or its first meiotic division will be arrested or will be suspended in prophase 1. Alright, in prophase 1, which states in the developing stage of meiosis 1. One more time. This primary oocyte has to undergo meiosis 1, meiosis cell division. There are two phases of meiosis. Meiosis 1, alright, and meiosis 2. These are the two phases of meiosis cell division. Clear? Again, meiosis 1 has got sub phases which is called 1, metaphase 1, anaphase 1, and telophase 1. Similarly, meiosis 2 has also got subphase which is called prophase 2. Alright, then metaphase 2, anaphase 2, followed by telophase 2. So therefore, this primary oocyte has to undergo first meiotic cell division. It has to complete the first meiotic cell division, but it will be arrested or suspended at the prophase 1. Now prophase 1 has also got different subphases, alright? So mainly in the diplotin stage, of prophase 1 of meiosis 1, the primary oocytes will be arrested or suspended. It will not complete its first meiotic division. Now only after attaining puberty, these primary oocytes will complete its first meiotic cell division. Yes, I'll write over here. So this primary oocyte has to undergo first meiotic cell division, and write meiosis 1, which will be reductional division. Till now, the chromosomal number in the primary oocytes will be diploid, 2n. Okay, so the primary oocyte has to undergo first meiotic cell division. Remember, it will be only completed once the female will attain puberty. Till that time, it will be arrested at the diplotin stage of prophase 1 of meiosis 1. So after attaining puberty, the primary oocytes will complete its first meiosis cell division, meiosis 1 cell division, which is called reductional cell division, and therefore these primary oocytes will divide into one small cell and a larger cell. That means there will be unequal cell division. Right, you can see the size or the shape of the cell. It will be unequal cell division. So I can write over here, there will be unequal cell division. So this tiny smaller cell with less or no amount of cytoplasm, this particular cell is called the first polar body, P-O-L-A-R, polar body or polocyte. Okay, and these larger cells with enough amount of cytoplasm is known as secondary oocyte. Yeah, so this will be known as secondary oocytes, and secondary oocytes will retain the maximum amount of cytoplasmic part. Now, what will be the genetic makeup of secondary oocyte? Now, since the primary oocyte has undergone first meiotic cell division or reductional cell division, therefore the secondary oocytes will be haploid. It will be haploid. And what will be the chromosome? It will be 22 plus X, because the sex chromosome of female is XX. Therefore, the ova always carry which chromosome? Always carry X chromosome. So 22 means autosome and 1X means the sex chromosome of the female. Clear? Okay, now. So till now we have done this clear for you. So what you have done till now? We have learned that the primary. So till now we have learned that the oogenesis begins from the time of embryonic development, that is the development of female fetus, and in 17,000 of primary follicles at the developing stage. Around second month of gestation, or let's say second gestational period, we will find around 6 lakhs of primary follicles, which will continue to divide by the help of mitotic cell division. Then in the fifth gestational period for the embryonic development, there will be around 7 million of primary follicles, and at the time of birth it will be around let's say 2 million primary follicle, because it will undergo the process called atresia, where there is shrinking of primary follicle. And after birth, not a single follicles will be added. Alright, so after birth, not a single oogonia or the single follicles will be added. And after attaining puberty, we have learned that the follicle has to undergo the meiotic cell division. So what we have learned over here, let's check it out over here. We have learned that the cells with germinal epithelium or the primary follicles keeps on dividing by the help of mitotic cell division or equational division. Will keep on dividing, and those cells will be known as oogonia. They have undergone multiplication phase. Then the second phase is called growth phase, where the oogonia has to increase in size, right? So when they will enlarge in size, they will be known as primary oocytes. The genetic makeup will be diploid since it has undergone mitotic cell division. Now these primary oocytes will be arrested or will be suspended because it has to undergo the first meiotic cell division. But this first meiotic cell division will be completed once they will attain puberty. Till then, it will be suspended at the diploiding stage of process 1 of meiosis 1. Only after attaining puberty, the primary oocyte will complete its first meiotic cell division or reductional division, leading to the formation of secondary oocytes and tiny smaller body called polar body. Remember, there will be unequal division of cytoplasm. Clear? So secondary oocytes will retain the maximum amount of cytoplasmic part. Now, we'll continue. Now the secondary oocyte has to undergo the second meiotic cell division or meiosis 2. Yeah, the secondary oocyte has to complete or has to undergo second meiosis cell division. Remember, the ova will be released from the ovary at the secondary oocyte stage. It will only complete the meiosis 2 when the sperm enters inside the secondary oocyte for the process of fertilization. If the sperm does not enter inside the secondary oocyte, then it will not complete the second meiotic cell division. Clear? But since we are talking about oogenesis process, so we have to keep on going. So let's say that our secondary oocyte has to undergo second meiotic cell division. Now where it will be suspended, like primary oocyte, we are suspended in which stage? Diploid stage of process 1 of meiosis 1. The secondary oocytes will be arrested or will be suspended in metaphase 2 of meiosis 2. Okay, so primary oocytes, its first meiotic divisions will be suspended in which phase? Process 1, diploid stage of meiosis 1 till it will not attain the puberty. Only after attaining puberty it will divide to form the secondary oocytes and a smaller tiny body called polar body. Now, these secondary oocytes will also arrested or will be suspended in which phase? In metaphase 2 of meiosis 2. Now, if this sperm has entered inside the secondary oocyte, then these secondary oocytes will complete the second meiotic cell division and forms a large haploid structure called the ovum or oocyte of the egg, and a smaller circular body called the polar body. Okay, and in fact this first polar body we can also undergo meiosis 2 and can form the two tiny polar bodies. So this we have to find over here the two polar bodies. So what are the end products of oogenesis? So we can say that the end product of oogenesis will be one haploid ovum or the oocyte or the egg and three tiny polar body. So this will be the product of our oogenesis. Clear? So, after completion of second meiotic division, the secondary oocytes will produce the ovum or oocyte, which will be haploid. And always remember that second meiotic cell division will be equational cell division. It will not be reductional, it will be equational cell division. So the first meiosis cell division will be reductional, where the diploid primary oocyte will change into haploid secondary oocytes, and the secondary oocyte will undergo second meiotic cell division, which will be equational cell division. That's why the number of chromosomes in the secondary oocytes and the ovum will remain the same, or it will be constant. So therefore, this particular phase is known as maturation phase. It will be known as maturation phase. So the first phase is multiplication phase, the second phase is growth phase, and the third phase is maturation phase. Now over here, you have to remember those stages where the particular oocytes will be suspended or will be arrested and will not complete the process of cell division. So first remember that primary oocytes will be suspended or will be arrested at diploid stage of process 1 of meiosis 1. Here, till the female will attain the puberty, it will be suspended over there. Once they will attain the puberty, then these primary oocytes will complete its first meiotic cell division, where there will be unequal division of cytoplasm, leading to the formation of smaller polar body with no or less cytoplasm, and the larger cells with abundant cytoplasmic part, which is called secondary oocyte. Now, when I told you that the secondary oocytes will complete its second meiotic divisions only when the sperm enters inside it to bring fertilization. Till then, it will be suspended in metaphase 2 of meiosis 2. And once the sperm enters inside it, then it will complete the second meiotic division, which will be equational cell division, leading to the formation of third polar body and a haploid ovum or oocyte, or let's call it egg. So these are the different stages or the different phases of oogenesis. Clear? Now, we will go through the diagrams from the textbook to make the concept clear. Okay, now we will see the structure of graphene follicle, we will see the structure of ovum or the egg, and even we also see the process of oogenesis from the diagram that is given in your textbook. Yes, we will do the diagram from the textbook. Okay, so begin with figure number 3.16, figure of oogenesis. Yeah, so let's take the first one. So the primary follicles, first they have to increase in number, and they will increase in number by the help of mitosis cell division. They will form a large number of cells, a group of cells which are called oogonia, and these oogonia will be diploid to N. Okay, it will be diploid in nature. So this particular process, it takes place during the fetal life, and during the embryonic life, during the development of female fetus. So the oogonia will simply keep on dividing in number by the help of mitosis cell division, right? Okay, then in the second phase, which is called the growth phase, it will simply enlarge in size and forms the primary oocyte. Now this primary oocyte will be also diploid. Right? Then I told you that these primary oocytes will be arrested in the diploid stage of process 1 of meiosis 1 till it attains puberty. Now after attaining puberty, alright, after attaining puberty, birth, childhood, puberty, after attaining puberty, these primary oocytes will complete its first meiotic division prior to ovulation. And what is ovulation? Release of ovum from the mature graphene follicle. So, after attaining puberty, this primary oocyte will complete its first meiotic division, which will be unequal division, because there will be formation of a small cell called the polar body, and the larger cells with the abundant cytoplasmic part, which is called the secondary oocytes. The genetic makeup of the secondary oocytes will be haploid. Clear? So primary oocytes will be diploid, will undergo first meiotic division after attaining puberty, and will form the secondary oocytes, which will be haploid. Now the secondary oocytes will complete its second meiotic cell division once the sperm enters it to ensure fertilization, or else it will be arrested in the metaphase 2 of meiosis 2. So after the sperm enters the secondary oocytes, this secondary oocytes will complete its second meiotic division, which will be equational division, resulting in the formation of a haploid ovum and the second polar body. So the end products of oogenesis will be 1 haploid ovum and 3 tiny polar body. Remember, from 1 primary oocytes there will be formation of only 1 ovum. In spermatogenesis, from 1 primary spermatocytes there were formation of 4 spermatids. But here in oogenesis, from 1 primary oocyte there will be formation of only 1 haploid ovum. So go to the figure number 3.16 and remember the genetic makeup of the chromosome number. So in the oogonia, in the primary oocytes, it will be diploid, the secondary oocytes, and the ovum will be haploid. The ova or the ovum from the Graafian follicle will be released only in secondary oocyte stage. Clear? So to ensure fertilization, when the sperm enters inside the secondary oocytes will complete second meiotic division and forms the ovum. Right now, only we call it the ovum or the oocyte or the egg. So the structure or the diagram of oogenesis. The next one, we look into the structure of a mature Graafian follicle. Alright, so go to the figure number 3.15. So this figure is very important, you have to practice it. So how to identify the mature Graafian follicle? So Graafian follicle will be formed from primary follicle to secondary follicle, then the tertiary, then finally it forms the mature Graafian follicle. Okay, so Graafian follicle contains the cavity. This follicle is called the cavity. Contains the cavity. Follicular cavity, we also call it antrum. And this antrum contains a liquid called liquor follicule. Yeah. Now, when we look into the structure of Graafian follicle, we will find 2 layers. We call it theca externa, externa means external part, and the inner layer called theca interna. Okay. Second one, we will find these follicular cells. These follicular cells are called the follicular cells where the ovums are suspended or present. We will call it membrana granulosa cells, or we will call it follicular cells. So these are the follicular cells. This is the cavity, we call it antrum, which contains the fluid called liquor follicule, and this one which we are seeing over here, this is the ovum. Okay, this one is the ovum. The structure of ovum we will discuss afterwards. So this one is the ovum. Now ovum are suspended in the follicular cell or in the granulosa cells by the help of this follicular cells, which is called cumulus ophorus. So ova will be suspended by the help of these cumulus ophorus in the follicular cells. So this is the structure of our mature Graafian follicle. It's called outer layer called theca externa, inner layer called theca interna, the follicular cells or the membrane granular cell. This one is the ovum, which is surrounded by a shell of layer called cumulus ophorus cells. So practice the diagram number 3.15. Clear? The next one, we look into the structure of ovum. Alright. Let's look at the structure of a mature human female ovum. Now this particular structure, they are the sperm, and this one is the ova part. This is the nucleus part, this is the ovum. So we will talk about that. Now when we look into the ovum, the general structures, it will be round, oval or spherical with a nucleus placed centrally, or it may not be centrally. Right, the nucleus present inside it. This particular ovum has got its own cell membrane or plasma membrane. Now, which part is plasma membrane or cell membrane? So, this particular layer, which you can see over here, we call it cell membrane or plasma membrane. We also call it vitelline membrane. We also call it vitelline membrane. VITELLINE. We also call it vitelline membrane. So this ovum or the egg that is own cell membrane or the plasma membrane or vitelline layer. The space inside the ovum have got two layers, the external layer and the inner layer. This external layer inside the ovum is called the exoplasm. We call it exoplasm. And the inner part that contains the nucleus part, we will call it ooplasm. We call it ooplasm. Okay. Then we will find the second layer, which is produced by the follicular cells.